So today we are going to solve this rotate array problem, and the question says that we are given a nums array and we have to rotate this nums array by k steps to the right, and k is not going to be a positive integer, and by rotate we basically needs to shift all the elements by a given number of times. So here k is given as 3. So what we have to do is switch each and every num inside it by 3 times. If we if we take 1, it will, after all the rotation, it should be at 1, 2 and 3. Wherever 4 is right now, 1 should be shifted to that position. So if you see the output, it took the place of 4. Likewise we have to do it for all the elements. But if you see the last few elements where we don't have anything to the right, what happens is basically this one. If you shift it to the right, it basically means it will come to the beginning, and then likewise for 6, it will shift to 7, and then it will come to the first place. So if you see in 7, it is shifted to 1, 2 and 3 here. So 3 times, right? K is equals to 3. So that is the reason it landed in that position. So it's actually a easy problem if we can use like a additional memory, but they are expecting us to come up with a solution of big of 1. I mean, we should not be using any extra space. First we will do by using an extra space, and then we will see how we can optimize it to a constant space efficiency. So to solve this problem, we can have another array which will rotated, let's say rotated array, and make of array of int, and the length is going to be length of nums. So for we'll loop through the nums array for index and value in range nums. If that the final index is going to be rotated at it is going to be idx plus how many times we have to rotate, it will be k, and in case we exceed the length of the array, we have to come to the beginning again, right? So for that we can use this mod operation, and we have to mod it with the nums array, length of that nums, and that will give us there we have to keep the value, that will be its new position. So so to explain this, if you take this example here, 7, the index of it is 6, right? So the final position for that would be 6 plus what is the value of k? 3. So it is how much is it? It is 9, right? But 9 is not within the range of this. That is the reason we mod it with the length of this array. So if we mod it with what is the length? If we mod it with 6, then we get the value as 3. Is it right? Yeah, I think so. 0, 1, 2, 3. Mod length of 1, 2. It's actually the length is 7. So the final mod, if we do it, then will be 2. So 2 will be the new index for this element 7. That's what we are doing here, if you see. So once this is done, they are checking the nums array itself, so we can't return rotated. So for that we can do copy copy into nums whatever we have in rotated array, and this is the final solution without a with a big of memory. So this will get accepted if you see. This is a pretty easy solution if you are allowed to use a space. So if we have to do it in like with constant without using any extra space, then we need to make some observation. It's not possible to come up with this solution in the first try, but I mean, I don't know who came up with the solution, but if you observe this, right, let's get the input. So this is the input, and this is the output. So if you see the whatever solution I am going to explain, it is purely out of observation. So if you see this, right, 5 6 7 and 1 2 3, we can come up to this point if we do three things. One, we first have to reverse this whole array. So it would be 7 6 5 4 3 2 and 1. And then once we reverse the whole array, we have to reverse the first three elements. Why 3? Because the k value given in this example is 3. So if we can do that, then it will be 5 6 7 and then 4 3 2 1. And as a final step, we have to reverse the last remaining elements after these 3. So if we do that, 5 6 7 should not should be here, 5 6 7 and 1 2 3 4. If you if you see, this is the expected output, and that is basically the solution. First, reverse the whole array, reverse the whole array, and then reverse the first k elements, and then reverse the remaining elements, which means k plus 1 to end length of nums. So this will give us the solution. If you ask me how we came up with this, I don't have an answer. It's just purely out of observation, and I don't know why this even works. So yeah, so let's code this. Let's see how we can code it. So I will have a function to reverse this, reverse and nums or array. It is going to be a referent and left and right boundaries. It is not going to return anything, it is going to reverse it in place. So for left is, as long as this condition is true, I am going to array at left, and array at right is equals to array at right and array at left. This basically swaps whatever we have in left index to the right and right index to the left. And once that is done, we have to increment the left index and decrement the right index. So this will take care of reversing. So first, as I said, first reverse the whole array. So in order to do that, reverse what the array we want to reverse, and left index will be 0 and right index is going to be -1, both inclusive. Once that is done, we want to reverse the first k elements, and for that we can do this. We want to reverse nums and from 0 to k minus 1, which will include the first k elements. And then once that is done, we want to reverse from k to whatever length last elements we have, and that should be the whole solution. I know this is not an easy solution to come up with, but yeah, I'm really sorry I can't explain you what the intuition is here. It's just some observation some guy did somewhere, and this turns out to be the efficient solution. Anyway, let's try submitting it. It seems to be accepted, which is expected because I solved it already. What? Yeah. So the reason why we got this error is because the k value, right, it could be greater than the length of nums. So if we are doing it, if you see here, reverse the first k elements, then it might be that uh, whatever k minus 1 value we are passing, it is greater than that array length. So when we do it here, we are going to get a index range index error. So for that we want to change k so that it is within the permitted limit, which is length of nums mod k. And let's see why it's not 5 6 7. No, it should be k mod length of nums. So to explain this first part, let me come down here. So let's say we have an array of 2 1 and 2. So if we say, if they gave k value to be 5, then if we don't do anything on the k, then we are going to get a range index issue here. So in order to counteract that, what you can observe is we have k value is 5 and the length is 2. So for the first two iterations, it's not going to change, or it's not going to have any impact on this. So for example, if we rotate it once, then it will be 2 1, and if we rotate it once more, then it will be 1 2, which is basically what we already have. So until 1 1 2 3 and 4, the first 4 rotations, it's going to be whatever we already have in the array. So if we, basically it's like cancelling out, right? What is the length of the array here? It is 2. So this is going to bring this 2. It basically means that 2 rotations is not going to affect the array, so we can discard it. Likewise, these 2 rotations is also not going to have any impact on the final array, so we can discard it. So basically, effectively, the k value is going to be 1, because that is the only iteration or the rotation which is going to change the given array. So in order to get that right, the number of iterations which are actually going to have the impact, we need to do mod. Because if you see in the previous case, 1 2 3 4 1 2 3 4, if we do it mod, first 2 is going to nullified, and then 3 4 is going to get nullified with this length of 3, and we are going to have only one iteration where the array will be actually changed. So basically, in order to get that value, we need to do k is equals to, here the length is k is 5, and if you do mod with the length of nums, then it is going to be 1. That's what I am doing in this line. So let's try submitting it. Yeah, and this is the complete solution. Anyway, thanks for watching. I know this is not a very intuitive solution, but yeah, it's leetcode, and we have nothing else to do. But in real world scenarios, we don't have to do this in a complicated way. We can just have an extra space, because these days memory is not like that constrained, so it's okay to use some extra space. Anyway, thanks for watching. I hope you understood the solution, and yeah, thank you.